many of the parts you'll be making will start with a rough piece of stock. The first operation you need to perform on a piece of stock like this is called squaring a part. And that means machining all of the surfaces so that they are flat and perpendicular to one another. You also, in that process, machine them to the nominal dimensions of your part. To start with, you want to set the part on the vise and find a concave face. You can see that this face is concave. That's stable. I'm trying to rock the part, and it's quite stable. This face, on the other hand, is convex. Now, if we try to lock this part in the vise using that face, we won't be able to lock it in securely, and the part is likely to move. So you want to start with a concave face. If you don't have one on the particular piece of stock you started with, put one in. Make sure that that face is up against the back jaw of the vise. Now, you can see here that this part is not square. See it moving as I try to tighten down the vise. In fact, when I've tightened down the vise a little bit, I can still move this part by hand. In order to clamp this part securely in the vise, take this little tool, if it deserves to be called even a tool. It's a piece of bar stock that has a flat cut in one side of it and a slight taper cut in the other. Now, by aligning the peak of the tapered part with the middle of the piece and with the concave side of the piece up against the jaw, we now have the right sort of stable contact to hold the part securely in the vise. And we want to start by orienting this part as much as possible so that it's level. So we have to remove the minimum amount of material. To help us do that, we put a parallel in the jaw of the vise, and without the vise being too tight, just tap this down until it's more or less aligned. As long as you've given yourself 1/8 of an inch to work with in roughing out the part and you're cutting it on the saw, this is not a very critical operation. If you're working on an existing part that has already been machined to size, you'll need to take the time to get this aligned very accurately. Okay. Now that we have this roughly aligned, make sure it's locked down in the vise securely. The tool I'm going to be using to square up this part is a fly cutter. We have here a single point tool that sweeps a large enough arc so that we get a continuous cut across the entire part. To set this tool up for use, bring the quill down until the tool just comes into contact with the part. Lock the quill, then bring the knee down. Back the tool off the part, and whenever possible, rotate the tool by hand to make sure that it doesn't hit anything. For the first pass, you should bring the tool in slowly by hand. Bring it in over the part. Bring the knee up slowly until the tool contacts the part. And then back the tool off the part, bring the knee up a little further. And now again by hand, begin feeding the tool across the part. You can see from this cut, the pattern that it's made, that this part was not at all square. This surface was cut. This is still original material. Now we bring the knee up a little further. That was about a 20/1000th of an inch cut. You see the finish, not very good, but it takes much less time to do that than it does to take many very fine passes. What we can do here now is, having rough machined the entire surface, take a finishing pass of about 2/1000ths of an inch. Now we can also use the power feed to give us more control over the feed rate and give us a nicer finish. We now have one of the 6 sides of the part machined flat. Preparation for machining the next surface, it's a good idea to remove any burrs that were produced in machining the first surface flat. It's very important when filing a flat surface with a flat file to apply the pressure through the middle of the part. If you try to file a flat surface holding the handle of the file, tend to rock, and the surface that was flat ends up having a crown in it. We're not trying to move a lot of material here. The purpose is to just remove any burrs that may be on the part. Now that we have one flat surface, the part, we put that surface up against the back jaw of the vise. We go through the same procedure as before, bring the tool end into contact, backing it off a little, bringing it off the part, making sure we aren't running into anything. Bring the tool over the part, bring the knee up until the part comes into contact. we now have two flat orthogonal sides to this part. Now we're going to work on getting a third side perpendicular to the first two. We start same way we did before by putting one of the flat sides against the back jaw of the vise. Snugging up the vise jaw but not getting it too tight. And then with a machinist square, we align one of the flat sides that we've already made with the edge of the square. This may be kind of difficult to see. A common thing to do is to put a white piece of paper up on the back of the machine to give you a white background. Now I'll tap on the part with the hammer gently, and you can see the gap starting to close up. There. Gap is closed, and now we are in a position to machine the third side perpendicular to the other two sides that we've previously machined. Lock the part in place, and then use a fly cutter in just the same way we used it on the first two sides. We now have three flat orthogonal sides to the part. For the fourth side, the part, a part this size, we want to use a parallel to allow us to space up the part high enough so that the top of the part clears the jobs and we can machine that surface. So we take one of the flat sides and put it on the parallel, and another flat side and put it up against the back jaw of the vise. Now as I tighten the vise down, something surprising happens. The parallel is now loose. What's happening here is, as I'm tightening down the vise is actually bowing a little bit, and the part's rising up off of the bottom of the vise. To deal with this, as you're tightening the vise, if you drive the part down into the vise with a soft hammer, you'll find that you can move the part down until it is again in contact with the parallel. However, if you tighten down some more on the vise, you'll find that it's loosened up again. If you're trying to hold very close tolerances on a part, it's very important to make sure that the part does stay down in contact with the parallel. That surface now is in firm contact with the parallel, so now we're ready to machine the fourth side. And this proceeds in the same way that machining the first three sides. Now with the surface clean, it's time to start measuring. Now hopefully at this point the part is still larger than the final size you're after. So what you do now is measure the difference between the size of the part now and the final desired dimension of the part, and continue machining until you bring the part down to the desired dimension. Now, the same procedure is used on the remaining two sides of the part. So we now have a part with 6 flat surfaces orthogonal to each other, and the part is now nominally the size of the finished part we're going to make. Many parts start out as pieces of flat plate. The piece I have here is roughly 2 inches by 3 inches. I've cut it out on the bandsaw to a size slightly larger than 2 inches by 3 inches. And I'm now going to machine the sides of this plate and bring the dimension down to the desired dimension of 2 inches by 3 inches, and in doing that also square up the sides relative to one another. Start by locking the piece in the vise lightly with a soft hammer, tapping the part down until this surface is relatively parallel to the jaws of the vise. That way we can remove the minimal amount of material. I lock the vise down firmly. Bring the tool into place, bringing it down into contact with the part, locking the quill, and then with the knee, pulling the part away from the tool. Now we bring the tool off the side of the part, and if possible, turn the tool. Make sure that it's not going to hit anything when you turn the machine on. Now bring the part under the tool and then slowly bring the part up into contact with the tool. The first pass you should take relatively slowly because there may be a fairly significant irregularity in this surface, and you don't want to be surprised when you hit that and the tool tries to cut too large a piece of metal. Now that we know that there are no large irregularities, we can use the power feed and take a larger cut. Now we have one side of the part that is smooth and flat. The next step is to machine the other side of the part parallel to the first side. Now we have the second side parallel to the first, but we still don't have the part down to the desired dimension. We measure the part, going for 2 inches. We can see here that we're 56 thousandths over the desired dimension. So now if we put the part back in the vise, making sure, as always, that there are no chips in the bottom of the vise to interfere with the location of the part. Lock the vise down lightly. Give it a few taps. And now we dial in .56 thousandths remaining to be removed from the part. I'm taking a fairly large cut here. If I wanted a smoother finish or better accuracy, I would get close to the desired dimension with cuts like this, but as I got very close, I would take smaller and smaller cuts until I got down to the desired dimension. By doing that, I minimize the deflection in the tool and the workpiece and get a very smooth, accurate cut. Now that we have two sides of the part parallel and brought to dimension, we'll work on the two remaining sides of the part. With a part with this sort of aspect ratio, we try to clamp it in the vise like this and machine across the top. The part is so flexible that it will chatter. So what we do instead, support the part on parallels like this. Again, tightening the vise down, snug, tapping the part in place with a hammer, make sure it's parallels. Check the parallels, make sure they're tight. This one's a little loose. Okay, that one's now tight. Bring the end mill in contact, run it across the face by hand. Move the part in a little bit to take another cut. We now have three faces of the part cleaned up. The fourth side of the part, we start out same as the third side, clamp it in a vise, bring the end mill, contact the part, and run it across the face. The pass I just took was about 5/1000ths of an inch. Any more than that, and you begin to get significant deflections in the cutter, so that the dimension of the part is slightly larger than what you would produce if you, with the same setting of the machine, took another pass on the part. So it's very important anytime you're measuring a part to have made the previous pass a finishing pass, or a very light pass, to minimize deflection in the tool and the machine. Now that we have the third and fourth sides of the part square, flat, we'll measure to see how close we're getting to the final dimension. I was a little casual with a bandsaw here, and I've still left myself quite a bit of metal to remove. I'm at about 118/1000ths over the 3-inch dimension I'm going for. So what I'll need to do is take probably 2 more roughing cuts, measure again, and then take the last few finishing passes to come down to the desired dimension. So I'll start by taking about 50/1000ths of an inch. And I'll take another 50/1000ths. Now that was a roughing pass. If I were to measure it now, I wouldn't end up at the correct dimension. Watch as I bring the tool back across the part. There's some metal being removed. The metal is being removed because there was a significant deflection in the machine and tool during the last cut. This shows why light finishing cuts are necessary to produce accurate parts. We are now 18/1000ths over size. So now what I'll do is I'll take one more roughing pass of about 16/1000ths of an inch, and then the final pass will be about 2/1000ths of an inch. Making the last pass that small, in this case, is done primarily so that I get a very smooth finish. Making roughing cuts removes a lot of metal, but it does not leave a good flat surface. So you do the roughing passes to save time. But when you're going for the final dimensions, for reasons of both accuracy and surface finish, you want to use very light cuts. before you can start machining features into a part, you have to locate the part relative to the spindle of the machine. To do so, you use what's called an edge finder. This tool has a little spring inside, allows the end of the tool to slide around. The way this works is you put the tool in the chuck, offset the tool so you can see it wobble. Now you bring the part out towards the edge finder. Now it's coming in contact, the edge finder, and the wobble is being reduced. Now continue turning the handle until the end of the edge finder jumps to the side. Now that tells us we have found this edge of the part. What we do now is set the machine to 0, either with the digital readouts or on the dials. Bring the part away from the edge finder. And come back into it again. We do this just to make sure that the first time we didn't overshoot. I'll show you if I intentionally overshoot by 3 or 4 thousandths of an inch, you'll see no change in the position of the end of the edge finder. It's very important to check to make sure that you did not overshoot. Once having reached this position, you have located the edge of the part, but the spindle is not centered over the edge of the part because the end of the edge finder is 200 thousandths of an inch in diameter. So what we have to do now is move the part half that distance, or 100 thousandths of an inch, and reset our readouts to read 0. Now we have, as you can see here, the spindle centered over this edge of the part. This procedure is repeated for the other side of the part, and then we know within 1,000th of an inch where this corner of the part is located. All features are then referenced from that point. A common operation on a milling machine is drilling holes. A milling machine is used in very much the same way that a drill press is used. Just like a drill press, we have a quill that moves up and down, a drill chuck. To start drilling a hole, we use a center drill. This drill is very short and stiff, so that when you start a hole with it, the cutting forces are not enough to push the drill around, so that the hole that you produce with this is very concentric with the axis of the machine. When using a center drill, you want to bring the drill down far enough so that you're up part way on this taper, but not all the way up on the straight part of the drill. So what you produce is basically a funnel that is then followed by the drill. Only go down about 3 or 4 drill diameters before bringing the drill back out and clearing the chips. Otherwise, you risk having the chips bind up in the drill. This particular alloy of aluminum, 2024, is relatively hard and machines dry. I mean the chips come off dry, they're not sticky, so they tend to move out of the way of the cut. So you can do much of the machining work on this alloy, on many plastics, on most steels, without cutting fluids. When you're drilling a deep hole, it's a good idea to put just a little bit of cutting fluid on the tool. That keeps the drill and the chips cool, keeps them from sticking to the drill or to the hole. You continue drilling the hole, taking about 1 diameter, depending a lot on the material, during each pass before you clear the chips. Now, if you're drilling a hole all the way through a part, make sure that there's some place for the drill to go on the other side of the part. I was not drilling this hole all the way through the part, so I left this parallel in place. If I was drilling all the way through, I would set up the part, lock it in the vise, and then remove the parallel. Now when I drill the hole, I can come through the part and not run into anything. Now you can hear during the cut the machine making some squeaking sounds. What's happening there is the cutting fluid has all been pushed out of the cut, and cut is now dry and is in danger of having the chips bind up in the hole. So with a little more cutting fluid on there, cut is going better, and we should be just about through. Okay, we're through. I intentionally set up this part a good distance off of the bottom of the vise. This was to allow me to pass through the part and have time and distance to stop before I struck the vise. You can't always do this. There are times when you just have to have a part very close to the vise or to the bed of the machine. If that's the case, before you start drilling, you should bring the drill down make sure it's not going to contact the vise, and then set the depth stop of the machine. With the depth stop in place, you can now concentrate on the cut and not on also at the same time worrying about stopping before you drill through your part and into the vise.